This question states, a satellite orbits the moon and has a 45-degree view of the equator. Find the degree of the arc that is visible from the satellite. I'm going to begin by drawing a picture. That's the moon. Satellite is somewhere up here. And it has a 45-degree view of the equator. This lets me know those are tangent lines, and they meet at an external point, the satellite. And it says it has a 45-degree view of the equator. So this angle inside is 45 degrees. And they want us to know, to find the degree of the arc that is visible from the satellite. That is the arc that we would like to know. So I'm going to label it as x. Because this is a circle, the little arc is x, or the minor arc. And we're going to say the major arc is 360 degrees minus x. It's the entire circle minus the minor arc. And we know that our relationship between the angle formed by the tangent lines, the minor arc, and the major arc is the difference in the two angles divided by 2, or half of the difference in the two angles, is equal to the angle measure. And then it's just a matter of solving this. So 360 degrees minus x, and then minus another x, is 360 minus 2x. Divide this by 2. Subtract, and then divide by the negative, and we have x is equal to 135 degrees. So the degree of the arc that is visible from the satellite is 135 degrees. Moving on to the next section, B. The average radius of the moon is approximately 1,080 miles. How far above the moon's surface is the satellite? Again, I'm going to draw my picture, the moon, and I'm going to put my tangent lines back in there. There's the satellite. And I know something different this time. I know a radius. So the radius from the center to the point of tangency is a right angle. And if I draw a line from the center to the point external to the circle, I form a right triangle. And something interesting about this is this line that I've just drawn actually creates two congruent triangles. It's easy enough to show that this side and this side are congruent because they're the radius of a circle, of the same circle. It's a right triangle, and then this is also congruent to itself by the reflexive property. And those sides are congruent also because tangents to the same external point to the same circle are congruent. So those are congruent circles, they are congruent triangles. And I would like to note that this angle then is congruent to this angle, making them half of that angle which we knew from earlier is 45 degrees. So one of these angles is 22.5 degrees. Now I also know that this is 1,080 miles. So I know an angle and I know the side opposite from it. I would like to know something about this middle side. And now I have enough information that I can use our trig ratios from a previous unit. So I will set it up. I'm using sine because I know the opposite side and I would like to know the hypotenuse. So the sine of 22.5 degrees is equal to the opposite side, 1,080 miles, divided by the hypotenuse, which I don't know yet. So I'll leave that as x. A little bit of solving here gets us that x is 1,080 miles divided by the sine of 22.5 degrees. And then on a calculator, I'll do 1,080 divided by the sine of 22.5 degrees. You want to make sure you're in degree mode. And this tells me that that hypotenuse is about 2,822 miles. But when I'm doing problems like this, I always like to go back and read the problem to make sure I've answered it. The question asks, how far above the moon's surface is the satellite? So we actually want not the entire x here, but we really just want this piece. So we know the entire length there is 2,822 miles, but if I take off the radius, which was this part, that's a radius. If I take off a radius, then I can see that that distance is going to be approximately 1,742 miles. There's also a part C to this problem, and it states, what is the length of the longest line of sight from the satellite to the moon's surface? So same picture that we've had this whole time. And it wants to know the length of the longest line of sight, which would be the tangent line. So I'm looking for this length. I'm going to use the same information from the previous problem. I know this is 1,080 miles. And I know that this angle is 22.5 degrees. This time I'm interested in the adjacent side. So I will choose tangent this time. So the tangent of 22.5 degrees is equal to the opposite, 1,080 miles, over the adjacent, which I'm going to label x. Again, some solving will tell us that x is equal to 1,080 divided by the tangent of 22.5 degrees. Using the calculator, we see that x is equal to 2,607 miles approximately. And that answers the question, what is the length of the longest line of sight from the satellite to the moon's surface?